Welcome back, students. Welcome to the lecture series on signals and systems. This is a continuation lecture for the study on elementary signals. And in this lecture, we are going to study about different kinds of signals, such as rectangular pulse functions, the Signum function, Sinc function, and so on. Okay, I'll just try to give you some idea about this some elementary signals which we are going to use extensively in our discussions in the further chapters. The rectangular pulse function, or this is also known as gate function. Rectangular pulse function. The unit rectangular pulse function is generally represented in terms of pi of t by tau, where tau represents the width of that rectangular pulse, and pi of t by tau mathematically is defined as 1 for within that pulse width, that is for t mod t less than or equal to tau by 2, and it is 0 otherwise. This is how we generally define mathematically the rectangular pulse functions, and it is an even function of t. We could see this by viewing the graphical representation of this function, where it takes the value of unit amplitude between the width minus tau by 2 to tau by 2. Therefore, the rectangular pulse width in this case is equal to tau, and the value of the amplitude during this particular period, it is equal to 1. And rest of all those values, for all the rest of the values of t, it is equal to 0. Okay, such kind of a function we generally say it as a rectangular pulse function. Sometimes this is also known as gate function, and in some books it is generally also represented as g tau of t, where g tau of t, where tau represents the pulse width, once again pulse width of this gate function. And you could see that this function actually exhibits symmetry, and this is an even function of t. And similarly, we shall define another function that we extensively use in our discussions, that is Signum function. The unit Signum function is defined mathematically as Signum function, Signum of t, generally represented as Sgn of t, which is equal to 1 for all t greater than 0, and you could see that it is equal to minus 1 for t less than 0. Okay, therefore, whenever we represent the graphical representation of Signum function, you could see that this signal will be taking the values of 1 for all positive values of t, and it is equal to minus 1 for all negative values of t. And this is how we generally represent the Signum function graphically. And you could see that the Signum function can be expressed in terms of unit step function, and it takes a value of something like this. Sgn of t can be represented as minus 1 plus 2 into u of t. We can generally take this values of Signum of t as minus 1 plus 2 into u of t. Whenever I consider 2 into u of t, it takes the values of something like 2 times of the amplitude. And whenever I subtract minus 1 for all values of t, you could see that this is equal to the value something like this. Okay, this is an exact representation of your Signum of t in terms of unit step function. And similarly, now I would like to define some another function called as the Sinc function. Now, the Sinc function might be known to you. You might have extensively used this function in your mathematics too. The Sinc function, Sinc of t, is defined as sin t by t for all values of t between minus infinity to plus infinity. And this Sinc function oscillates with a period of 2 pi and decays with increasing values of t. Okay, whenever t goes on increasing, the amplitudes of the Sinc function goes on decreasing. its value is 0 at n pi. Sinc of t will be equal to 0 at values of n pi, and for all n is equal to plus or minus 1, plus or minus 2, and so on. And it is also an even function of t, and we could see this. We could see the graphical representation of the sinc function. As said, it takes a maximum amplitude at 0, and the amplitude goes on decreasing with the values of t increasing on both sides. Okay, it is equal to 1 at 0, and this is how a sinc function is actually represented. And you could see that this is also an even function. Sinc of t is also an even function of t. And that's all.